All right, I want to welcome everyone to another Earth to class, and we're very pleased to welcome back Margie Turrin, she, her, hers. Margie's going to talk about the Polar Climate Ambassadors Program. And obviously, this is one of those situations that needs no introduction from me. So Margie, wait a moment while I connect you as co-host. Okay, you should be able to share your screen now.
Okay, that sounds great. So I'm assuming that it is at this point shared.
We got it. Thank you.
Yeah, of course. So I am going to talk about the Polar Climate Ambassadors Program. I'm also going to talk about some of the other tools that we've developed actually working with teachers. So we did an RET, a couple of RETs actually this summer. And we had some teachers that worked on some really great resources. So I want to make sure that we kind of show you some of the things they did because they're really quite great and hopefully useful for you all. So let's see if I can get my slide to advance. So before I start with advancing things, the Polar Climate Ambassadors logo you'll see up on the right, and that was developed by a group of our summer interns this summer. We had high school interns that are Polar Ambassadors, and we'll be bringing in a new group this summer. So I have some information on that at the end of the slide. And if you have any students that would be great candidates, that would be wonderful. The link to the website is actually a link to some of the things they developed, some of the resources we use. Yeah, I'm going to be continuing to update it. There are many more resources that I haven't managed to get loaded yet, but they did a remarkable job. And my motivation for doing the Polar Climate Ambassadors is these projects that you'll see all lining the left-hand side of the slide. I work on a whole range of different projects. 4 of these happen to be in around Greenland and Arctic, and then one large one that's focused on Antarctica. And in each one, you know, the importance of the poles in controlling and driving climate and the impacts and connections to us are so strong. And yet I think that they're so misunderstood or understood and undertaught. So wanting to try and make sure that we reach out to students and get that information to them. So in the time we have today, I'm going to talk a little bit about an introduction and the importance of the poles. I know a lot of you already know this, or maybe you all do, but it's always really nice to kind of refresh our understandings and kind of look at that. We'll look at some critical messages that the poles can tell us and what do they mean to us. And then we'll go into those tools, and I'll end by how to link into the Polar Ambassadors Program for students. So first, I always like to start with this whole representation matters. And I think that as we've moved into more of a satellite age and we've gotten much more technologically savvy in the classrooms, we have the ability to do more. We have moved a little bit away from just looking at the poles with a Mercator projection, but Mercator projections are really not doing justice to any kind of understanding of the polar regions. They stretch Antarctica out along the bottom of the map, and you can't really get a scale sense of it. And the Arctic is kind of, again, diffuse and really not connected well to the rest of us. So I am a strong advocate for bringing in this polar stereographic display. And it really right off kind of centers for you the differences between the Arctic and the Antarctic, how the Arctic is an ocean that's surrounded by land. It's so evident when you look at it this way. And that Antarctica is a continent that's surrounded by ocean and really pretty disconnected from most of our land masses. So, you know, this is a great way to kind of pop and bring these things to light. So again, just a way to kind of change the way that we're doing this. The other thing that I think is really important in terms of representation is just bringing in the inclination. And I know that I think probably most of us here do a lot with earth science. This is our primary bread and butter, but it's just not reinforced enough, I don't think, that that inclination is what makes those polar regions so very different, allows them to collect all that ice, and really helps them with driving that climate. So there many years ago, I was at AMNH, and there was a group that created this little ditty, 23.5 degrees, the earth is tilted naturally. And it's just kind of always hung in my head. So little things like that that can really help with trying to reinforce ways that students can learn are always useful. And then one other thing that I think before we start that's really important to hit heavily is the fact that there are polar amplifications going on. They are feeling the changes much more rapidly, and they're driving the changes because of that polar amplification. So because the atmosphere and the oceans, everything's transported to both poles, they're really being hit. But they're also, I mean, this works for cooling and warming. So right now, of course, we're in this big warming trend. Yeah, we're really being impacted by the warming piece. But in fact, when and if we ever change back into a glacial cycle, we will see the cooling is also dictated by this. So again, this polar amplification. And then feedback. So in this particular feedback loop, you'll see that the positive feedbacks are actually all connected here to ice cover, to water vapor increase because of that ice cover change, and changes in permafrost, releasing methane. All of those are polar. And then the negative ones are kind of residual on that. So the role of the poles in those feedbacks and how important they are, and helping students understand positive and negative feedbacks, really important. Okay, so that was a very quick, just kind of representation. So why would we want to teach about the polar regions? So there are three big things that I think about. They're climate regulators, and we'll talk about each of these a little bit. They're great archives, so they have all these wonderful proxies that really tell us about past climate. And then they really are harbingers of our climate future. They're kind of accelerating everything forward and telling us what's possible in a very short time frame geologically. So in terms of climate regulators, we just mentioned a little bit how atmosphere, these high pressure zones, they influence winds and atmospheric patterns, and everything is transported to the poles. So very much a part of our global climate with that global transfer of winds. The oceans, through the formation of sea ice, we see the freezing of the ocean surface is dropping down the salt. And so that's changing density. And then you have this fresh water coming off of glaciers and ice sheets, which is adding a freshwater lens. And of course, that's a huge driver of global circulation and heat distribution. And then we have that also is responsible for this wonderful upwelling in the Southern Ocean, which is really important in terms of absorbing significant amounts of CO2. So we'll take a quick look at that thermohaline circulation. Just again, this is a great way of connecting students to how these regions are not isolated. They really are an incredibly important part of how all of this heat is redistributed around the Earth system. So then in terms of ice, we have this highly reflective surface. You can see a little picture up here in the right-hand corner. It's, this sending back that energy, rebounding the solar radiation and helping to cool our climate. And that is perhaps one of the most concerning pieces with our changes in the pole, is just that really strong change in that ice albedo, especially with the loss of Arctic sea ice. And we'll look at that in just a second. And then, as we've mentioned, we have these wonderful archives and harbingers of our future. So in terms of kind of looking at these different locations, we have complete opposites, right? So as we mentioned, we have an ocean that's surrounded by land and land that's surrounded by ocean. And I'm sure you guys are probably aware of this, but I've become more and more aware of this, that this idea that the Arctic is an ocean surrounded by land is a very, it's something that doesn't hold. Students seem to forget it. People seem to have lost it. It's like this persistent misconception that the North Pole is on land. Maybe everybody's got a vision of elves and Santa. I don't know, but it's a very strong, persistent misconception. And so the more that, again, this kind of goes to showing this polar stereographic image, the more that we can reinforce that this is an ocean that's covered by a very different kind of ice. So this is sea ice, right? Rather than having this really thick land ice. It's really, again, something to reinforce. And of course, that white reflective surface is all about sending that message of albedo and how that's really keeping us from absorbing all of that heat energy that's coming in. And as we lose the ice, that will be changing. And then there are also different kinds of ice that are aside from sea ice, aside from glaciers, we have these two massive ice sheets. And I love this representation because it's really looking at the thickness, the elevation of those two ice sheets. So if you take a look at this, you can see that the Greenland ice sheet, it really rivals the Himalayas, and in terms of elevation, and Antarctica really rivals the Andes. And if we take a peek at that, you can see that there are, almost 3 kilometers of ice thickness in Greenland and close to 5 kilometers of ice thickness in Antarctica. So huge reservoirs. So aside from this albedo, those reservoirs also have an impact on us. Of course, if they move into the oceans, that changes our sea level. So the potential that's in those big ice sheets is really, really important. Okay, so we'll kind of move into these. I have 8 different messages that we'll look at quickly, and just what's going on in the polar regions and why they're important for us to pay attention to. So the first message, of course, is this big loss of Arctic sea ice in both thickness and extent. This is a picture from 2012, which actually this was from March. I happened to have been up there on a project. And interestingly, later that year, we had the largest sea ice minimum in the summer that we have had to date. It had to do with a atmospheric circulation. So again, that tie to atmosphere that kind of just shoved all of this, not only annual ice, but a lot of multi-year ice out of Fram Strait. So we've lost that. Very difficult to re-establish, especially multi-year ice as our oceans warm. So we haven't rebounded to where we were. We haven't seen that dramatic a loss since, but we have certainly seen some significant loss. And what I wanted to do was show you a product that one of our students did on sea ice. So this is one of our polar ambassadors this summer. This is Janice. She was a high school senior, and I'm just gonna play this for you because I think you guys can see this, right? Actually, can you hear me? Can you hear that video?
We're not hearing the video at the moment.
Okay, I'm gonna, I think what I forgot to do was when I started, wait, when is it? When I start remind me how to do this, guys. I'm sorry. I think that we'd be all so great at Zoom, but I haven't used Zoom in a while now. So let's see. I am going to stop sharing. I think when I start sharing, yes, share sound. Okay, I'm on my game. All right, can you see the video though?
It's in freeze frame right now.
Yeah, that's fine. I just want to make sure that the video is showing. Okay, I'm going to kind of tip through.
And enjoy
Okay.
effortless,
Yes.
unrestricted
And you can
breathing
hear it.
We're
Okay.
hearing it now.
Okay, great.
Unlike the Antarctic, the Arctic is a vast ocean surrounded by land. This vast ocean is blanketed with miles and miles of sea ice, or a thick cover of free-floating frozen seawater. Sea ice has been declining in recent years due to warming air and water temperatures, a result of climate change. Not only has the extent of sea ice been declining, but the actual thickness of the ice is decreasing too. In 1980, the average thickness of sea ice was about 3.64 meters, which is about 12 feet, or the height of 2 American refrigerators stacked on top of each other. In the past 40 years, that number has been cut in half, now measuring at about 1.89 meters, about 6 feet, or 1 American refrigerator. So, why should we care about the loss of Arctic sea ice? Well, maybe you've walked on black pavement before, barefoot, and if it was on a sunny day, you might have noticed how hot it felt. In comparison, lighter surfaces like the sidewalk don't seem to get nearly as hot. That same idea actually applies for our oceans. Sea ice, being white, has a higher albedo than oceans, meaning it's better at reflecting solar energy. As less sea ice forms, oceans can't reflect energy as well, absorbing more energy from the sun and warming the surface of the water. This absorption results in warmer sea surface temperatures, causing more sea ice to melt, and it puts us in a vicious loop called a positive feedback. The Arctic also supports and is surrounded by all sorts of wildlife that are dependent on the sea ice for survival. And with the loss of sea ice, unstable weather patterns may result from more moisture in the atmosphere. The formation of sea ice is also important to global ocean circulation. The water in the ocean is salty, and when sea ice forms, it forces the salt out of the water. This makes the water underneath sea ice saltier and denser. This dense water sinks, which creates deep ocean currents, and the surrounding surface ocean water gets pulled in to replace that sinking water, and the process continues. The formation of Arctic sea ice is crucial for driving that global ocean circulation, commonly called the ocean conveyor belt. If this cycle weakens, it will change ocean currents, impact marine life, and change weather patterns globally. The poles are absolutely critical to maintaining the health of our planet and are hit especially hard by climate change. Factors from all across the globe are contributing to climate change, so it's important that we turn towards our own communities and see which changes we can start making to protect our poles. We encourage you all to take a minute and think about one more thing that you can do to help reduce your carbon footprint, and be sure to check out and add to our list of suggestions.
Okay. So are you back with me on the slideshow?
Yes.
Okay, sorry. I just need, I can, whatever I see on my computer might be different than what you see. So first of all, I want to say that Janice did that whole script herself with, you know, some back and forth. We gave her some input and some resources, and she developed it. And then, of course, she recorded it and put together the graphics. She asked me for some pictures that she was hoping to use, and we had some conversations. But this was a great way for Janice to learn something really cool, but it's also a great resource to share young person to young person, student to student about, you know, what they've learned. And I think she did it in a really kind of engaging way. She's so she's so sincere. You just have to love her. But you know, this whole idea of the Arctic sea ice is really critically important. What's driving the change there? You know, how it's changing, uh, why we should care, its role in all these multiple Earth systems. She introduced positive feedback loops, and then she ended with a call to action. And she had, you know, her fingers stacking with the refrigerators and stuff. I really think she did a great job. So, you know, again, this is kind of the thing that these polar ambassadors do, is that we work together to kind of craft these things, and then we get them out sharing them. So
Margie,
that
how
was,
is it available?
say it again.
Where is that available?
Oh, so I can go back to the QR code in the beginning, but it's on our Polar Ambassador page. We have, if you go actually onto the Lamont website, there's a Lamont education, and under that you'll actually see the Polar Ambassadors program, and our webpage is there. So that is linked on there. And they created a whole bunch of, well, I'll show you a little bit more about the people they talked to, but they created a whole bunch of great videos. So we'll look at a couple of others too that are a little bit shorter, but yeah, that was a good one. Okay, so our second message from the polls, again, whoops, I don't know how I did that, is that that our oceans are warming. And of course, that's really critically important in terms of connecting with the polar regions and melting the ice that's present there. So again, we have this floating ice in the Arctic that is just sitting in the water and so has a harder time actually forming. And we've seen in the Arctic that this trend is a degree C of increase in temperature over the last 4 decades. So, that's per decade. So that's 4 degrees. That's insane, right? And, this is really, it's driving change in not just, of course, our sea ice formation, but also in terms of, if you remember, it has this evaporation transfer with the atmosphere. So it factors into this entire climate system. And so I want to just go. So in Antarctica, you can see around Antarctica, it still looks, especially in East Antarctica, it still looks as if it's retaining its cooler temperatures. But when you get over to West Antarctica, you can see that we're seeing significant warming going on. Both of them have been increasing, both on the east side and the west side have been increasing. And in certainly in this area over in this side of Antarctica on the west side, we're seeing about a degree C in 4 decades. So not as radical as the Arctic. That's about a quarter what the Arctic is, but still significant. And really any amount of warming when you're in this environment and you're resting up against the ice is important. So that's one of the biggest driver, not one, the biggest driver of change in Antarctica is the warming oceans. In Greenland, for that ice sheet, the biggest factor is actually it's shifting. It was atmospheric temperature, and now it's kind of almost half and half with ocean and atmosphere. And one of the things that I want to point out, I think I did this, did I? We'll see, and if not, we'll pop back to, yep, I did. So I want to point out that this area where you see all this incredible warming, again, this side of Antarctica especially is all sitting below sea level. So anything that's blue here is below sea level. This Western Antarctica is an archipelago. It's just a series of islands that's just been all frozen together through accumulated ice over the years, and now that's just sitting in warming ocean water. And there are these incredible pathways where water can get, these are very deep, these deeper blue, water can get way up in and under and cause more melt from the base. So we're seeing really big changes from this warming ocean temperature. Sorry, let me go back and point out one other thing, and that is these ice shelves. So you'll see shelves. This is this light gray that's sitting here. Antarctica is surrounded by over 40 ice shelves that are where the ice sheet has gone afloat. So as the ice sheet is being pulled by gravity down from the center where it's at its highest, being pulled towards the edges, and it goes out and kind of expands out over the surface of the ocean and stays connected to the land on all of these back sides. And those ice shelves are extremely vulnerable because they are sitting on top of this warming ocean. And so this is a picture of the front of the English coast ice shelf, kind of over here on the peninsula. And you can see how it just rests in this water. And as that water gets warmer, of course, it's going to be melting more and more. And as those shelves melt, even though they're already sitting in the water, they release this land behind them. Excuse me, not the land behind them, but the ice sheet behind them. So the glaciers come flying in, so that land ice behind them. Okay, our third message is going to be this warming surface or air temperature. And this is where you're really seeing significant changes. This is that polar amplification that I mentioned early on. We're seeing that the Arctic is warming 4 times faster than the rest of the globe, and it's very evident in any kind of imagery that you can pull. You can see how the mid latitudes are they're seeing warming, but 0 would be like the white areas. Yeah, everybody's seeing warming, but we're way up here in terms of degrees Celsius in the Arctic, and of course also the Antarctic Peninsula and around West Antarctica. And this has been increasing. So the last 8 years are collectively the warmest 8 years on record for the Arctic. And that is certainly significant. I'm sure you all saw that 2023 was our warmest year of record. So we're certainly not seeing anything reverse. And again, just to point out, the peninsula area is really significantly warmer than so it almost matches the Arctic. It's noticeably warmer than West Antarctica, but of course, West Antarctica is sitting up on land, whereas, as we mentioned, this part is sitting in the ocean, and our thickest ice is over here in East Antarctica. Okay, our fourth message is about those ice shelves, so that they are thinning and collapsing. You can see that there are ice shelves. Again, these are just some of the bigger ones. I've done a little circle here where we have 2 that are changing quickly and are showing the biggest changes in Antarctica. One is Pine Island Glacier that kind of goes up this way, and there's an ice shelf, Pine Island ice shelf down here, and then Thwaites Glacier and Thwaites ice shelf here. And this is a picture of Thwaites. And I always like to show a picture because when we think about ice floating on top of the ocean, we don't think about how thick this ice is. I mean, this is like 600 meters. This is a lot of ice. It's a stable, very stable platform. We have camps that are set up on them. It's not as if it's this, it's not like the Arctic sea ice in any way, shape, or form, even though, as Janice told us, that's just still a lot more ice than just a skim of ice. But this is significant. And the idea that these were stable was in our framework for many, many years. And then we started to see change. So in 2002, we saw the Larsen ice shelf disintegrate in 6 weeks. And so we'll just click through this disintegration. And that ice shelf was the size of Rhode Island. So that went away between the end of January and the middle of April. So, 2.5 months, right? Which seemed like a lot. But then just in 2022, we saw this ice shelf collapse over here. And you see Bowman Island. So you'll see that this collapsed between February and March 21st. That's a month, right? So this really stable section of East Antarctic ice right here on the shelf just, disintegrates. And as these shelves collapse, we see the ice, as I've mentioned, you see this land ice just accelerating off. And we have some really great data that was collected when Larsen did that. We had some wonderful measurements and some good satellite imagery. And that was the first time really they were able to see that really strong link between the ice shelves and the ice sheet itself. So this is something that we're hoping not to see a whole lot more of. Okay, and then the last couple of changes are actually in land ice. I always love this picture because it really puts the scale of Antarctica into our minds. Antarctica is 98% covered by ice, and it is really massive. This is a picture that I took, in 2016 or something, and you can see this little zodiac of people going into land. I was back on the boat, but you really can get a sense of just this sheer magnitude of ice that's down there. And so Antarctica has a lot more ice on it than Greenland. It's a lot larger. There are 7 Greenlands could fit in Antarctica, but Greenland is also has this massive ice sheet, and about a little over 80% of it is of the landmass is covered by it. And again, the differences of 3 kilometers of thickness at the center versus in Antarctica, it's 4.7. So both significant. And in both instances, when you pull off the ice, you see that the land has been depressed by just all of that ice. Okay, so the next message that we have then about this land ice is how it is, we're increasing the number of melt days. So over on the left, you see a series that was collected from 79 through 2007, and it's in a nice GIF, so I like to show it. And you can see how this ice melt is increasingly moving in towards the center of the ice. Again, remembering that there's a big elevation difference in ice between the edges of Greenland and the center, where we have 3 kilometers stacked. And then on the right, you'll see that this is a snapshot from 2023. And so that trend has continued. You'll see the white is the only area that didn't have any surface melt. That is an amazing visual to see that just this very, very high summit area was free from melt. And I'm sure that some of you will have heard that there was actually rain up on summit. So it is, things are changing, right? We're really seeing, this is days of melt, by the way, on this scale. So number of days that we had ice melt. And then on the surface, you see where we had actual melt occur. So definitely things are changing. And as we just noted, they're moving further up on the ice sheet. When you have surface melt, you get these little meltwater channels, and those collect in these meltwater lakes. And those lakes can then force open and pop down into moulins, which are these channels that can take warm temperatures, warm meltwater from the surface to the base in a matter of minutes to hours, versus thousands of years if you have to melt all the way through the ice. So they have a significant influence on what's going on. And you'll see, if you look at this graphic, you can see these little black ticks are actual observations where we're seeing these meltwater ponds moving up further on the ice sheet itself. The purple lines are projections or models that are helping us look into the future and think about what might be coming our way. So from 71 to 2012, you'll see that they spread inland by 53 kilometers. So that's 33 miles that they moved inland. Again, significant. And this is a model that was derived from that work, just showing where we might be going in the future. So this is like the center of the ice sheet, a little bit shy of the thickness, but you can see that by 2050, we're almost up at the summit, which is concerning for sure. Antarctica, a little bit different, but still you're seeing that these areas where we have melt, we have the peninsula, one of our more exposed areas. You can see around the edges, of course, not a big surprise. A lot of the shelves, the ice shelves, which are around the edges, are seeing melt days, increased melt days. Yeah, we're seeing this being another message from the poles. Our 6 out of 8 messages is that ice is flowing faster off the land. And so I pinpointed our fastest flowing in both, the fastest in Antarctica is Pine Island, and the fastest that we have in Greenland is Cermak-Kosciuszko, and that is, it's also called Ilulissat or Jakobshavn. By the way, there is a push to try and use the native Greenlandic names in the glaciers. They're trying to make sure that we start to put that into our vocabulary out of respect for their history on the land. So And they're even respectful of the fact that I totally butchered the way to say that, because they just want to make sure that they're recognized. So they're very forgiving of that, just in case you wondered. So again, these fast flowing areas are increasing as they move and moving more ice off the land into the ocean. And our seventh message is the loss of glacial ice elevation. So I know in talking, I had a talk one time with one of the ice bridge scientists who had started the ATM program way back when, before ice bridge was even a thought. And he said the first year that they went up to monitor using aircraft, they were really worried that they wouldn't be able to detect with their ATM any kind of change over, between year 1 and year 2. And, they said we would need to see about, at that stage of development, about a half a meter of change. And they were amazed when they went back and saw that it had changed by 4 meters. Well, this is even more significant than that. This is 20 meters of change over 4 years. And you can see the snowfall in that area is a half to a meter annually. So really seeing the changes on some of these glaciers. This again is that Pine Island Glacier that I was mentioning. And just to show you, again, just to kind of give you a sense of it, this is Pine Island ice shelf at the front of the glacier. Again, it's a significant amount of ice. Sometimes when we think about, oh, these changes, these drops or whatever, we don't really realize just the magnitude of ice that we're talking about. So big changes. And then our last message that I'm going to talk about is just this loss of ice mass. And I think it's interesting to look at the mass loss image from Greenland and Antarctica and see that in Greenland that it's really pretty much distributed around the entire landmass. So you'll see there are very few areas where we're not seeing a big loss. Of course, you can see that on this kind of mid to northern, western section of Greenland, we're seeing the biggest loss now. And again, this is an area where the ice is kind of right up against the ocean. But reminder, in Greenland, we're seeing both atmosphere and ocean are probably equally driving change there now. Whereas in Antarctica, it's mainly ocean-driven melt. And you'll see that area where we looked at Pine Island and Thwaites, this is a really important area. And even though those are small ice shelves and seem small glaciers, as those ice, remember we were talking about those ice shelves, as those ice shelves disintegrate, they release a lot of this glacial pull behind them, and this would drain this whole bigger section. So everything's connected in here. So there's a very big concern, and you're seeing that this big loss is happening. There are, by the way, people, I'm just going to mention this, there are people who will say, oh, look, we're accumulating ice. And I've seen even some papers come out on that really focus heavily on the fact that we are accumulating ice in certain areas of Antarctica. And that's great. But still, if you look at the overall trend, it's down. So while we're accumulating in some areas based on atmospheric patterns and blocking, and this area, the Cam Glacier stopped flowing, and so it's kind of hit a ridge, and now it's going to accumulate back here. That doesn't mean that overall the situation has shifted. And just to kind of give you a visual, that this area right here, this area right here is where this picture was taken. So you can see there's a lot of ice there to go. And it's literally just right on the edge of the continent. Unlike Greenland, where sometimes it's at the edge and sometimes it's protected in by fjords. Okay, so those are our 8 messages. All of the last 4 related to land ice. And in land ice, there's only one thing to remember, and that is that it's always about moving ice from the land into the ocean. And that changes sea level. There's no way around it. So that's what's going on with all those shifts into in the land ice. In the sea ice, it's part of that accelerated warming. As we lose that ice, we're going to have that feedback amplification, and it just really helps feed the whole global warming cycle. These warming ocean temperatures are accelerating the melting of sea ice and land ice. And again, that's going to feed that whole system of warming. Warming surface temperatures, again, going to melt more ice, reducing barriers for keeping that cold air in the Arctic. So we have more chaotic weather, which we've been seeing. And then the collapse of those ice shelves is, again, just releasing more ice into the oceans. So those are all the messages. Those are all the reasons why we really should be teaching more about the poles in what we do. It's really kind of almost a lost topic in many ways. So really trying to make sure it becomes more part of what we do regularly. Okay, I want to step into the 2 teacher products that we had come out of this summer. Daria Hilsman, who is a high school chemistry teacher at Spring Valley High School, worked with us this summer. She really kind of came in not knowing exactly what she wanted to do and how she wanted to take the project. We were very interested in trying to tie into her chemistry background and do a little bit with paleochemistry, and trying to figure out how to link it to schools and students. And so she said she wanted to take it. She had her own vision. She did an amazing job, and she took it in a variety of different ways. I just want to show you a couple of parts of her project. So first we'll go to the modern day climate changes on the poles, because she really got interested in the impact on people, which I thought was really interesting and fun. I hadn't expected that she would go into that. I'm just going to zip down until we get there. But she really wanted to make sure that the residents of the Arctic were represented in what she did. So let's see. Here we go. So she really wanted to introduce their faces. She has linked in a variety of videos. I won't play this one, but this is one that's called Happening to Us. And it's all of the videos that she uses are short, but it really speaks from the voice of natives and talking about what they're seeing, how this is impacting them, and how they're really feeling it and trying to deal with it in terms of on a daily basis. Then she talked again about the fired stewardship through Indigenous voice. And then she got into PFAS, and I don't know how many of you talk about PFAS or even think about PFAS with your students, but it has become, it's this forever chemical that is part of our environment at this point, and has really been a topic of conversation because it's in our drinking water, it's in, it's just everywhere. And we have not figured out how to deal with it. We don't know how to actually remove it, and we're still continuing to add it. And while I was in Greenland this summer, actually, an article came out about Eastern Greenland and how the people of Eastern Greenland are actually have some of the highest, if not the highest, concentrations of PFAS in their bodies. And that's because of their lifestyle. It's the way they eat, it's the way that they are, how they connect with their environment. And it's just a really jarring story, because the way, I was talking with the people that we were staying with, and their comment was, this is how we were brought up, this is who we are, this is our lives, and we're not going to change the way that we eat seal blubber, whale blubber, we eat seal skin, we eat all of these places where we eat the fats. This is what we've done traditionally, and this is our comfort food, and they don't want to change it, and they shouldn't have to. But it's now becoming a real issue for them. So it's in, I don't know, just so you can see how it's manufactured, and everything that it's in, it's just ever present. So Daria, being a chemistry teacher, went into a little bit of the chemistry, which is wonderful. And then there's another really wonderful video that's in here that, again, I won't, out of time, won't share with you, but really a beautiful video in an Indigenous voice about a world that's kind of out of balance. Let's see. Okay, I'm gonna go back. To my, am I gonna go back? I am gonna go back, she says. All right. Why am I not gonna be able to go back? Can you see my PowerPoint?
Yes.
Yes, no? Okay, good. All right. And then she did another section that was on paleochemistry, and I want to show it to you quickly for one reason. So this is a really great intro to all the different proxies that we use to understand climate in the past. Proxies are something that is really great for students to understand, so they know how we actually tie these things. There are 5 clues to Earth climate history here. This is a really nice video that we won't go into, but just so you know it's there. And then there's one other wonderful video that she put in here that I think is really a neat one to share with students, and it's about uncertainty. I don't know if you guys have seen it before. I had not. She found it, and I think it was really important. It's this one called "Why is Uncertainty Important?" And it really showcases the role of uncertainty in science and how critically important it really is. So it's a basic part of doing science. So again, she did a fabulous job. So that was Daria. And then this was Alejandro, and Alejandro is an earth science teacher in New York City. And he created this beautifully done story map himself that has 4 parts. It goes through climate change, it looks at Arctic and Antarctic, then dives into Greenland, and then it goes into this project that we were doing where we're looking at changes on the ice surface with the formation of these meltwater ponds and how they're interconnected and what they're doing. And so he did a really great job. One of the great things about what he did is that all of these are activities that are embedded in it. So each one of these is a worksheet or has a linked video with a worksheet, and all of that is available. They can be downloaded or whatever. They're really quite nicely done. And he kind of did a tour of the Arctic. So he used his ArcGIS to kind of build in that. And then we kind of pop into Greenland, and he introduces Greenland. And again, he has these great worksheets, and he has videos embedded. And so you can do a tour of Greenland, and then taking you down to his ice flow tracking and analysis. This is a great activity that looks at GPS. He uses this engaging little polar bear, Nunnik, as where's Nunnik? And they have some clues, and these are their clues, and they're going to go and try and locate Nunnik. And then there are other things they can locate. So kind of a nice engaging way to introduce GPS. And then he has a second activity that looks at how we use GPS in science to look at glacier movement. And then this really great activity on hydrofracturing, which again ties into these moulins and things. This is using some imagery created by Woods Hole. There are a series of images that the students have to order to kind of look at how these things form, and then they match them with the text that goes with it. So it's a great activity to just kind of help them think about sequencing. So this is a really wonderful, he did a really wonderful job. He had done an internship with NASA, so he was very fluent with this particular tool. So did a wonderful job. So again, this is a great resource. And these things are linked, by the way, on the Polar Ambassador page and on our Polar Education pages, all of which come off education pages at the Lamont. So just kind of end by talking a little bit about our Polar Ambassador program. The goal was really to get them engaged. I really wanted to inspire first, then inform and activate, as we've learned from climate education. Just informing isn't enough. You really have to get them excited about it. So we spent a lot of time just digging into the polls and kind of getting excited about them. This was our group from last summer. We had 6 students. They were awesome. And they really improved their polar literacy, their climate literacy, their data literacy, their systems thinking. I mean, they really did a wonderful job, and their communication skills. I didn't put that in, but they worked hard. So we have, and through the year, we also work with environmental clubs, service groups, climate groups. I'm working with a New Jersey Hiking Heroes Club to kind of have different groups working. So they're all different ambassadors. And then we have this summer intensive, is what I call it, where they come together and help develop resources. I want to show this video. This is a way to reach youth is by really immersing them in their own kind of tools. This is Q. She is Greenlandic. I don't know if any of you know her. She's on Instagram, TikTok, etc. But what she does is talk about her country. And she's really, she does an amazing job of really connecting the culture and the people. She did an interview that I'll just show you quickly. I wish they didn't start all these this way, but we'll. Okay.
Inanuk content creator from Greenland is making sure the world knows the truth about her home country.
Every time I go to new places, I just realize that people have no idea about anything about Greenland. There's even people who don't know that there are people living in Greenland.
Kupanuk Olsen is the creator of Q's Greenland, a TikTok and YouTube channel with over 500,000 followers across platforms. Her videos focus solely on Greenland, a country colonized by Denmark, and her Inuit culture.
It's important because we want our voice to be heard as well. When you've been in a colony, it's like you feel under pressure, and we have been industrialized so fast that it's like our culture haven't been able to keep up. So I think it's important to show our culture, to tell our own story, and change the law regarding to our own needs instead of the European or Danish law requirements. Because the cultures are so different from each other.
Though politically considered European, Greenlanders migrated to the island through Canada for thousands of years. Cultural elements like language and Arctic cuisine are relatable for her many Inuit fans in Canada.
We have the same way of hunting, the same way of understanding the nature, being one with the nature, and there's so much of our expressions with no and yes, with our facial expressions, with our culture, they're the same. So we have so much in common, and our languages are almost the same because it comes from the same root.
Today we are comparing our Inuit language between Nunavut and Greenland.
With over 400 videos made and millions of likes and views, her internet fame is catching up with her in real life.
I've become really, really famous in Greenland. That is a bit annoying at the moment. I can't go out my door without being recognized. So I'm actually thinking to buy some caps today, so I can just hide a little bit more. I'm getting so much attention at the moment that it's getting a bit difficult.
But Olsen says no matter where her videos may take her, Greenland will always be special.
I've traveled to so many places around the world and realized how lucky I actually am, because our nature is so beautiful. We can go out hunting. We can feel like the Aboriginal feeling we all supposed to have as human beings out in the wild. So we still have that here. So we are pretty lucky.
Sab Jonesa, APTN National News, Winnipeg.
So one thing that I wanted to point out is that she ends every video with that comment that life is amazing, which is kind of her tagline. She's very positive, which is not uncommon when you meet people in Greenland, and just really happy to be Greenlandic, which I think is important for a lot of our students to hear. I won't play this, but this was done by our students, and it's a lovely video. It's very short; it's just a minute, but this is Ali Balter, who's one of our scientists, and she lived with a group of reindeer herders in Norway, Sami, and she was amazed when she went. She wrote a grant so she could go and report on how they were dealing with climate change, and she said when she got there, she found they were living it. They weren't dealing with it. They were just adapting and figuring out how to do it, and on a daily basis, because it was their lives. And so it was very impactful for her, very impactful for the students. These were all the people that our students interviewed. They did videos, little bits of videos that linked all of them together on similar topics. And then they did like a little dive into each scientist, but they're all very short. They're all available on our website. They also did these, we had some already archived 60-second videos from some people on a different project. And so they kind of did these information cards on them. But you can see a lot of what they heard from our scientists was how they were really wanting to include an Indigenous voice and to work with the Indigenous people in their science. And that really rubbed off on them. So you see when they did an exit interview at the end, out of the 6 of them, half of them were, one of the most important things they learned was kind of a polar fact, and the others was about people, which I thought was really fascinating, that piece, whether it was that there are lots of careers in the poles and it doesn't have to be a polar scientist, it can be a driver or a chef supporting the crew or a data scientist. This youngster, actually, this young person was interested in computer science. And so he saw modeling as something that was interesting to him. But then we had this, Sia was the one who did the video on Ali, looking at the native population and how it's part of their day-to-day life. And then Janice really got interested in this whole idea of extractive science and how even the people that are in the Arctic and we're working around them, not only is our science non-inclusive in the research, but we don't even share it back with them half the time. So that was really impactful to her. They also created a lot of resources, like this is Arctic, Antarctic on either side, the sediment cores from the Arctic. So different proxies and ways of telling sea level rise. Carly is using these perched lakes and looking at the fossils that are in them to tell about past sea level. And our team down in Antarctica is using penguin bones and seashells to look at where they were left on an island. So 2 different ways. Both of them, of course, end up using, a combination of radiocarbon dating, et cetera, but it's kind of fun to look at. And then this like kind of local to global connection in the center. We also had, this was one of our combined videos that the students did that looked at what scientists' advice about what we can do to fight climate change. They were very interested in solutions. So they put together a solutions page, and then they put together this, everybody was asked, what should we do? And they put together this very fast-paced, fun video, which is also on our webpage. But the biggest thing that came out of it was them. They were amazing communicators. They did a bunch of teach and reaches where they met with other students, interns that were here, and other people that were here and shared their newfound knowledge. And they also went to the pier and did some interviewing. One of the things that Ben did when he was down there was he wanted to build on a study that had been done previously. This is a study that was done in 2016 that looked at a U.S. understanding of the Arctic. And what we found this summer was in gray, what Alaska natives in 2016 responded, and what the other states in 2016 responded is in blue. So we have gray, orange, blue. And you can see that we seem to have a better understanding of the fact that sea ice is definitely on the decline, has not recovered, and covers much less than it did 30 years ago. But in terms of what's the biggest contributor to sea level, we're still behind the 8 ball in terms of understanding that it's actually the land ice that's the biggest contributor, not Arctic Ocean or melting glaciers. That I told you already, this kind of misconception of the fact that the North Pole is actually sitting in an ocean. That the only people that were better at that, even they were not all that great, was say Alaska Natives. And then the fact that the US actually has territory in the Arctic, still kind of seem to, we've certainly improved in terms of the lower 48. So that was kind of a fun thing to do. And of course, the biggest takeaway they all was that they wanted to share was that the poles are so critically linked to Earth's climate and that we're changing them. So we are recruiting right now for a group of students for this summer. If you have students, students, it's an in-person program, so they do have to be in this immediate area. We have some funding. We'll probably take anywhere from 6 to 8 students. It is a lot of fun, and I really enjoy them, and I think they take a lot away from it. We've stayed connected. Several of them want to come back again. So that's all fun. And with that, I will stop sharing. And
Thank you very much for a wonderfully informative program. There's one person on
Absolutely.
here that I'm going to ask. Divya, will you unmute yourself? Divya, can you unmute yourself, please? Divya is a high school student who's looking for something this summer.
Oh, Divya, where is Divya in high school if she's unable to unmute?
Let's see, can I unmute?
I don't know. Mine says I can ask to unmute, but I don't know if I can unmute her. Do you know where she's in high school?
I forget because she's been around for a while.
Okay. Okay. Well, we can always share this, and she can, follow up.
Yeah, I have her email. I'll make certain that she follows up with you.
That sounds great.
Also, I'll
sounds
be
great.
sending you a request for links that I can put up on the Earth Class website.
Yeah, I had a lot of links in there, and I started doing QR codes, and I was like, how many people sit there with their with their phone and screen all that? So I figured that we could do that afterwards. But there are some great resources that I would really love to have people take advantage of. So it's really fun when students create resources and when teachers do. They're just, they really kind of get right what's important. So I enjoy it.
Very good. Other questions and comments? Anybody want to unmute and ask?
Would you accept community college students to this program? Or is it only specifically for high school students?
I hadn't even thought about it, Adam, but I don't see any reason why we wouldn't. I think that's a great idea. They are also at a great stage in terms of taking it all in and sharing it. They have a great cadre of fellow students to communicate with, which is what's important. And they're creative in terms of being able to generate things. So yeah, absolutely.
All right, thank you.
Thanks for even mentioning that.
Okay.
Okay.
Hope everybody has a wonderful day. I don't know what the weather's like back in New York.
It looks pretty good. Cold, but good. It's definitely on a cold spin. So
Yeah, we haven't had rain starting here yet, but we're going to see what happens.
All right. All right. Well, thank you all.
Thank
Have a
you.
great Saturday.
Okay, I'll be sending out information about next month's Earth class. We have 2 with some of our friendly scientists, Ben Bostock and Mike Kaplan.
Cool.
So I'll be getting the information out to everybody. Okay. Have a good day, everyone. Bye.
Bye. Thank you.